Continuing with section R.5, factoring polynomials, we want to look at another use of factor by grouping. When factoring, a factor doesn't come in common with every term, but it does occur in each of several groups of terms to make up that polynomial. So we can use factor by grouping. In these cases, we will use this when we have 4 terms. Okay, so you'll notice example 5 and 6, these aren't trinomials, they have 4 terms. So this is another use, right? Previously we broke it up into 4 terms, but now what if we encounter a polynomial of 4 terms? Always, excuse me, if possible, you factor out the G, C, F, then we'll do the grouping. Then we'll factor out the GCF from group 1 and group 2, just like we did before. And then we'll factor out the common factor, and you can always multiply to check. Okay, so we'll start with example 5, part A, factor this 4-term polynomial. Notice that there's nothing I can pull out with the x's because 12 doesn't have an x, but there is a GCF of 4, 8, 6, and 12. What is it? Yes, it's 2. So let's get that 2 out and see what's left. 2x cubed minus 4x squared plus 3x minus 6. Okay, so factor by grouping says we pulled the GCF out. Now we're going to group the first 2 terms. This is where I like to use my brackets to keep things nice and orderly. First 2 terms are 2x cubed minus 4x squared. Second 2 terms are 3x and minus 6. Okay, so then I've grouped them, and now I'm going to factor out the GCF of this group and the GCF of that group. Okay, so this group has a GCF of 2 and x squared, leaving behind x, what? X minus 2, right? We can do a quick check. 2x squared times x, 2x cubed, 2x squared times negative 2, negative 4x squared. Good. And here, of course, we can pull out a 3. And notice we know factor by grouping is working because we've got these 2 terms and they both have an x minus 2. That's the idea. It doesn't always work, but we can see it has worked, so we can continue. This is 2 times. Now I take out the x minus 2 from both of those, pull it out, and what's left? 2x squared plus 3. Okay, so I'll leave the check for you, but you would multiply, you can either multiply these 2 first, and then that result times the second binomial, or you could FOIL these and then distribute your 2 through. I think I'd FOIL and distribute the 2, but it doesn't matter, however you like to do it. Okay, let's look at the second one here just to get a little extra practice. Again, we look for a GCF, and we do find one. 3, 12, 6, and 24 share a common factor of 3. Don't be afraid to pull out your calculator to check stuff like that. Just divide everything by, 3 would be the only number because 3's factors are 1 and 3, but it's worth a shot, and just pull out your calculator and do it. X cubed minus 4x squared plus 2x minus 8. Okay, there's our 4-term polynomial. Keep the 3, don't lose it. It's very important. Without that 2 there, I'd never get back to this answer. So I've got to have my 3 brackets. Group the first 2. Notice I'm not having that problem of a minus sign right here, so I don't have to remember to always put a plus and keep these the same like I showed you before. Okay, so we've got 3 times. The first group has a common factor of what? X squared, yes. So that leaves us with x minus 4. And then here, 2 and 8, we'll pull out a 2, x minus 4. We're on track for factor by grouping. All right, so we have 3. These 2 share an x minus 4. Let's pull those out. What's left? X squared plus 2. And we can check.